Hello, and welcome to this session, Learning Outcome, LO2, Understand Specific Immune Defense Mechanisms. Today, we will explore how the adaptive immune system targets specific pathogens, recognizing particular antigens, and developing long-term protection through immune memory. The specific immune response begins with antigen recognition. Antigens are unique molecules on pathogen surfaces. Specialized immune cells identify these antigens, triggering a targeted reaction. This process sets the stage for a precise immune response. It's the body's way of distinguishing foreign invaders. Lymphocytes play a key role in specific immunity. B cells produce antibodies when they recognize antigens. Activated B cells become plasma cells, producing antibodies to neutralize pathogens. T cells support and regulate the immune response. Cytotoxic T cells destroy infected or abnormal cells directly. Memory cells are crucial for long-term immunity. After infection or vaccination, some B and T cells become memory cells. These cells remain in the body for faster future responses. They enable the immune system to react more effectively upon re-exposure. This is why second infections are often less severe. Specific immune responses are slower during first exposure. The body needs time to recognize antigens and produce antibodies. Once memory cells are formed, future responses are quicker. This rapid response is due to the presence of memory cells. It ensures a stronger defense against repeated threats. Acquired immunity develops after birth and is divided into active and passive forms. Active immunity involves the body producing its own antibodies. Passive immunity involves receiving antibodies from another source. Active immunity is long-lasting, while passive is short-term. Each type serves different protective roles. Active immunity occurs when the immune system produces antibodies. This happens naturally through infection or artificially via vaccination. Memory cells are formed, providing long-term protection. However, it takes time to develop. This type of immunity can last years or a lifetime. Passive immunity involves receiving antibodies from another source. It can occur naturally, such as from mother to baby. Artificially, it happens through antibody injections. Passive immunity offers immediate protection but is short-lived. It does not lead to memory cell formation. Active immunity involves the body's production of antibodies. It leads to long-lasting protection and memory cell formation. Passive immunity provides quick, temporary protection. It involves receiving ready-made antibodies. Active immunity is slower to develop, but more durable. The immune system comprises organs, cells, and molecules. These components protect the body against infection and disease. Key immune cells include lymphocytes, phagocytes, and antigen-presenting cells. Lymphoid organs like bone marrow and thymus are crucial. Immune proteins such as antibodies and cytokines play vital roles. The humoral response involves B lymphocytes and antibodies. B cells recognize antigens with helper T cells aid. Activated B cells become plasma cells, producing antibodies. These antibodies neutralize pathogens or mark them for destruction. The humoral response is effective against extracellular pathogens. Cell-mediated response involves T lymphocytes. Helper T cells release cytokines to activate other immune cells. Cytotoxic T cells destroy infected or abnormal cells directly. This response is vital against viruses and intracellular pathogens. It does not rely on antibodies. Primary response occurs during the first antigen exposure. The immune system takes time to recognize the pathogen. B and T lymphocytes are activated, producing antibodies. Memory cells are formed during this process. Symptoms are more likely as the body learns to fight the pathogen. Secondary response happens upon re-exposure to the same antigen. Memory cells recognize the antigen immediately. The immune response is faster and more effective. Large amounts of antibodies are produced quickly. Symptoms are often mild or absent due to this rapid response. Primary response is slower and weaker, with no prior antigen exposure. Secondary response is rapid and powerful, thanks to memory cells. Antibodies produced are more specific in the secondary response. This explains why vaccinations are effective. Repeat exposure usually results in milder illness. Humoral response uses antibodies to target pathogens in fluids. It is effective against bacteria and toxins. Cell-mediated response relies on T cells to destroy infected cells. It is crucial for dealing with viruses and cancer cells. Both responses are essential for long-term immunity. Vaccination primes the immune system for future encounters. It introduces antigens without causing disease. Memory cells are formed, allowing rapid future responses. Vaccines mimic the primary response, making secondary responses stronger. This is why vaccinated individuals often experience milder symptoms. Memory cells are the backbone of long-term immunity. They remain in the body after an infection or vaccination. Upon re-exposure, they enable a quick and efficient response. Memory cells ensure that repeat infections are less severe. They are crucial for effective vaccination strategies. Adaptive immunity is specific and long-lasting. It involves recognizing specific antigens and forming memory cells. This system targets pathogens precisely. It provides a tailored immune response. Adaptive immunity is crucial for fighting infections and forming the basis for vaccinations. Immune responses can be slow during first exposures. Pathogens evolve, sometimes evading immune detection. Memory cells help, but aren't foolproof. Vaccination strategies must adapt to new threats. Continuous research is essential for maintaining effective immunity. Immunology is a rapidly evolving field. New vaccines and treatments are being developed. Understanding immune mechanisms is crucial for disease prevention. Future research aims to enhance immune responses. The goal is to create more effective and targeted therapies. In conclusion, you now understand how these mechanisms form the basis of long-term immunity. By supporting and strengthening these processes, long-term immunity can be effectively achieved. If you have questions, message us on WhatsApp at 074843616888. See you at the next session. Thank you for your attention.